Welcome class to our video notes session on Skill 5 from Unit 3. This video will focus on adding and subtracting rational expressions. And rational expressions are just that. They are ratios, right? Basically fractions. And if you can think back to when you were first learning how to add and subtract fractions, the main thing that was emphasized was that you have to have a common denominator in order to add or subtract fractions. That's not necessary for multiplying and dividing, right? We just multiply straight across. But for adding and subtracting, we first need to get a common denominator. So this video will actually just look at adding fractions that already have common denominators. It will also look at how to find common denominators. And then our second video on this skill will actually go into how to add and subtract fractions that don't begin with common denominators. Okay, but for this video, we'll call this one part 1. We will focus on what to do when you do have a common denominator. So basically what you do is add the numerators. Okay, that's pretty much it. You add across the top. You need to understand that you do not add the denominators. Those stay the same because the denominators are kind of like terms. They're telling you the common thing that both of the numerators are being divided by. So they're letting us know that it's like a like term, but it's not something that we add, okay? We just have to recognize that the denominators have to be the same in order to add the numerators. Now, because we are dealing with rational expressions that have variables possibly in the denominator, we do need to remember to exclude anything that would make the denominator 0. That's unique to algebra, right? Unique to rational expressions. And then also we might end up having to simplify at the end. So if you can, then you have to, okay? So we'll look for common factors and simplify if there are any. But really, the main thing is you add across the top, okay? And then subtracting is no different. The only thing that you have to remember when subtracting a rational expression is simply to distribute the negative to the numerator. Other than that, you're basically following the same addition steps that were listed here. Add across the tops. Keep the denominators the same because all they are really are just like a like term. Do not let the denominator equal 0, so we restrict anything that would cause that to happen. And then if possible, we look to see if there's ways to simplify at the very end. So in our first example 1, we can see here there's an addition problem, right? The plus sign tells us that we're trying to add these fractions. And then we're fortunate enough that they already have common denominators. And so that means all we have to do is add across the top. Okay, I just have to add 2x plus 7 to 3x minus 10. So when I'm adding algebraic quantities, I again look for like terms. So 2x and 3x can combine to equal 5x. And then positive 7 and negative 10 can combine to equal negative 3, right? Positive 7 minus 10 is negative 3. And then all of that is over the common denominator of x minus 3. So I don't add these together because these are also kind of like a like term. This is saying, okay, 2x plus 7 is being divided by x minus 3, but so is 3x minus 10 is also being divided by x minus 3. So since they're being divided by the same thing, I can combine them together through addition. And so now I know, well, really 5x minus 3 is being divided by x minus 3. So it's just keep the denominator the same. Looking at that denominator, though, we recognize that we don't want to let x equal anything that would cause it to be 0. So we set the denominator equal to 0 and find out what that x value would be. And I can see that x cannot equal 3. So when I add these fractions together, I get 5x minus 3 over x minus 3. So that's my answer. It's already in simplest form. And I recognize that in order for these two fractions to exist and be able to add together, x can't be 3. Moving to example 2, I now notice, okay, this is a subtraction problem. I'm subtracting the second fraction. And so I have to be aware that since I'm subtracting an algebraic quantity, I'm subtracting this whole binomial of 2x minus 5, then I need to distribute that subtraction to both terms. Okay, so I need to understand that this is 8x plus 3 minus 2x plus 5. Okay, 8x plus 3 minus 2x plus 5 all over the common denominator of 3x plus 4. I'm I'm combining all of these like terms, and they all have a common denominator of 3x plus 4. But the 2x turns negative, and the negative 5 turns positive, and then now I can combine like terms. I can do 8x minus 2x, and that's 6x, and then positive 3 and positive 5, which is positive 8. That is all being divided by the common denominator of 3x plus 4. Okay, now you might be noticing, 6 and 8 have a factor in common. They have a GCF of 2. And if I factor it out, then the 6 turns into a 3 and the 8 turns into a 4, which is in common with the denominator, right? So then I notice, wow, I actually have a common binomial factor in the numerator and denominator, which can cancel out. When you have one identical quantity divided by itself, we understand that those two things divide to equal 1. Right? So this is just turning into one big 1, and 2 times 1 equals 2. So then all I have left is basically 2. So this was interesting. These two fractions up here, when I subtract them, leave me with just a numerical value of 2. But that's only if x is not equal to negative 4/3, right? So these two fractions have to be defined in order to subtract and equal something. And I notice that if I take that denominator and set it equal to 0, and then solve for x, right? So I had to subtract 4, and then now I have to divide by 3. I can see, okay, if x were equal to negative 4/3, then 3x plus 4 would equal 0, and I can't let that happen. But for all x's that aren't negative 4/3, these two fractions subtract to equal 2. All right, so then in example 3, again, I have a subtraction problem. Okay, I'm subtracting these two fractions. I have a common denominator of 3x minus 15. So I can go ahead and just subtract across the top, right? So I see, okay, this is really x squared minus 25 all over the common denominator of 3x minus 15. And then I can also tell in the numerator that actually what I have there is what we call a difference of squares. Because x squared is a perfect square of x, and 25 is a perfect square of 5. So I know that this binomial will factor to equal x plus 5 and x minus 5. Because if you notice, the middle term is missing here. It goes straight from an x squared to no x. The term that has x to the first power is missing, and that's because if I added negative 5 with positive 5, I'd get a 0. And then if I multiply negative 5 and positive 5, I get negative 25, which is why it's a difference of 2 squares. So these are the factors of x squared minus 25. Then in the denominator, I notice a GCF of 3. Both 3 and 15 can be divided by 3, and so I factor it out, and I'm left with x minus 5. And so I notice, okay, this is another scenario where there was a common factor that could divide out to equal 1. Right? X minus 5 over x minus 5 is 1. So we say that we can cancel these out because it just leaves a 1 behind. And then the final answer would be x plus 5 divided by 3. Or you could think of that as 1/3 times x plus 5. Either way, dividing by 3 or multiplying by 1/3 mean the same thing. Now again, for this problem, we just have to make sure to exclude 5. X can't be 5 because the only way we can subtract these fractions is if they actually are defined, right? We can't subtract them when they're dividing by 0. So we set that denominator equal to 0 and solve for x. And then we recognize, okay, if I set 3x minus 15 equal to 0, I'd add 15 and divide by 3. X can't be 5. Or you could look right here when I factored out the 3. If I plugged in 5 for x, right, 5 minus 5 would be 0. So basically, these two fractions subtract to equal x plus 5 over 3 as long as x is not equal to 5. So the next part of this video is kind of prepping us for part 2. It's prepping us for when we have to add fractions that don't have common denominators. And that is, we're going to have to find a least common multiple between two denominators. So that's why sometimes we call it an LCD. The D is for denominator. Because what we're basically doing is finding a least common multiple. Eventually, we'll be finding a least common multiple of the denominator, so we call it a least common denominator. These steps right here are going to be extremely useful to you, not only in this unit, but in all units to come, and really just in any other math classes you have to take from here on out. Being able to look at some numbers or algebraic quantities and figure out the lowest common multiple between them will help you so much. And then you're going to absolutely have to use it in this unit when we're having to add or subtract rational expressions. But basically what we do is we look at the factors of each number or quantity separately. Then we use anything that they have in common. And then we list whatever is remaining besides the common factors, and then we multiply those together. This skill or practice will help you quickly identify a least common multiple or least common denominator of multiple numbers or quantities. Let's look at just numbers first, okay? Let's look at something like 5 and 10. Actually, first thing I want to point out before we do that is what a common multiple really is. What is a common multiple? Okay, so a common multiple is a number, and then I'll put in parentheses, or quantity, right, when we're dealing with algebra. It's a number or quantity that the other numbers, the common multiple, we're looking for a common multiple of the other numbers, right? So it's a number or quantity that the other numbers or quantities multiply into, okay? So the common multiple we're looking for is a number or quantity that the other numbers, the ones we're working with, or quantities, multiply into, okay? So as a result, the common multiple is always bigger. It's always bigger than whatever numbers we're currently looking at, because it has to be a number that they both multiply into. That is the reason why we want to be able to find the least. Right? We want to find the least common multiple that they both multiply into so that the number doesn't get too big, right? So let's take example, let's look at example like 5 and 10. Okay, so I could think of lots of common multiples of 5 and 10. I'm going to just write a few examples down here, right? 5 and 10 multiply into a lot of common things. And I'm going to just list a few: 20, 30, 40, 50, etc. 5 and 10 multiply into all of these different numbers. And as I go on, the numbers only get bigger, right? So the goal of a least common multiple is really focused more on the word least. Can we find the smallest number that both of these will multiply into? And the answer is yes. It's not even one of these on the list. The answer is 10, right? 10 is the least common multiple between 5 and 10. Now, let's use this process here to see how that works. So first I look at the two different numbers or quantities that I'm trying to find an LCM of. Well, 5 really is just 5 and 1, right? Itself and 1. 10 can be broken into 2 and 5 and 1, I guess, but 1 is really not needed. So maybe I'll just erase it here because it's a multiple of every number. So I noticed that 5 really only has one multiple, itself and 1, and then 10 has 2 and 5 and 1. So the least common multiple between the two of them would first take the common factor of 5 and then list the remaining factor of 2, and then you multiply that together and you get 10. So the least common multiple of both of these numbers, 5 and 10, is 10. And it is a common multiple because 5 times 2 is 10 and 10 times 1 is 10. So 5 can multiply into 10 if I multiply it by 2, and 10 can multiply into itself if I multiply it by 1. So that's another thing to keep in mind, is a number is always a multiple of itself, because if you multiply a number by 1, it equals itself. So never forget that, because that can be really useful when we're trying to find the lowest common multiple. But anyways, 10 is the smallest number that both 5 and 10 multiply into. Okay, sometimes though, they won't have any common factors. There is always that possibility, like when you have numbers like 7 and 9, they don't have any common factors, right? In fact, 7, again, is just 7 and 1, and 9, you can break into 3 and 3. But you can see here, there's no common factors. So the LCM of 7 and 9 would just be 7 times 9, right? 7 times 3 times 3, which is 63. That does happen sometimes. But it's only when they don't have any common factors that you would just use the number that you get when you multiply them together. Looking at example 6, I've got two numbers here, 12 and 20, that again have a lot of common multiples, but the common multiples between 12 and 20 are rather large. Like one that I'm thinking of, some common multiples would be like 120, for example, right? 120 is a common multiple because that's just 12 times 10, right? Or I could think of that as 20 times 6. So it's a common multiple. 12 can multiply into it, 20 can multiply into it, but is it the least? Is it the least? Another common multiple I can think of would be if I just multiplied them together, 240, right? Which is just 12 times 20. So that's another common multiple, definitely not the least, right? Because it's already more than 120. So, and these numbers are both rather large. So the question is there a least common multiple that they both go into? So let me show you how we could find that using this process. So I start by factoring the two numbers, right? 12 is 2 and 2 and 3. 2 times 2 is 4 times 3 is 12. 20 is 2 times 2 times 5, right? 2 times 2 is 4 times 5 is 20. So these are the list of the prime factors of 12 and 20. So when I go to find my LCM, I take the common factor of 2, and then I have another common factor of 2, and then I list the remaining factors, 3 and 5. So my LCM will consist of 2 and 2, each for the common factors, and then 3 and 5 for the remaining factors. And when I multiply that together, I get 2 times 2 is 4, times 3 is 12, times 5 is 60. 60 is also a common multiple of 12 and 20, but it's the lowest common multiple, right? It puts the L in LCM. Okay, let's just double check. So I know that 12 times 5 is 60, so that's a multiple of 12. Is it a multiple of 20? The answer is yes, right? 20 times 3 can equal 60. So it really is a lowest common multiple of 12 and 20, and here's a quick handy way to find it. Okay, but that was with numbers. Let's take a look at some things that involve algebraic quantities. So let's take a look at number 7. In number 7, you have two binomials, and we're trying to find a lowest common multiple between these two. That can be a daunting task, but this process I feel like could really help simplify it for you. At least that's what I hope will happen. So let's look at the factors. Okay, we've been working a lot with factoring lately, and I feel like you guys are getting so much better at it. I hope you feel the same way. But let's look at the factors of these two. Hopefully you recognize x squared minus 9 is a difference of squares, right? It's got two perfect squares that are being subtracted. So that will factor into x plus 3 and x minus 3. And as a quick reminder, it's because the middle term is missing, right? There's no term with an x, and that's because positive 3 plus negative 3 is 0. So the middle term is basically a 0. And then positive 3 times negative 3 equals negative 9. That's why my last term is negative. At any rate, these are the two factors that multiply together to equal x squared minus 9. And with 4x minus 12, I noticed that there's a GCF of 4. I could take out a 4, and when I do, I'm left with x plus 3. So I can see, okay, I've got a factor of 4 and a factor of x plus 3. So that was step 1, factoring, right? Step 2 is to list the common factors. So they have a common factor of x plus 3. So I will take that one, okay? And then step 3 says to list the remaining factors, which are 4 and x minus 3. I think I'll put the 4 in front just because that's how we typically write these things. And so there's my LCM. And I'm not going to multiply it all out now, because when we eventually start using these things, you'll notice we don't necessarily need to multiply it out. We just need to find it. We need to figure out what are the factors of the least common multiple, and here they are. So the least common multiple of x squared minus 9 and 4x plus 12 is 4 times x plus 3 times x minus 3. And I'll put a little star by this because this is something we will need to use when we have to add or subtract fractions with unlike denominators. So stay tuned for the next video to see how we use this. Okay, let's try another one with algebraic quantities. So here I have a full-on trinomial, right? Full-on trinomial. So I'm going to use trinomial factoring where I have to find two numbers that multiply to 2 and then add to 3, which would be 2 and 1. And then because my leading coefficient is 1 for this, I can just skip right to the factors. So the factors of x squared plus 3x plus 2 would be x plus 2 and x plus 1. Okay, and then the second expression is, it's just itself, right? It's kind of like a prime factor. It just multiplies by 1 to equal itself. So here's my two quantities. Here's the list of their factors. And so to find the lowest common multiple between them, I take the common factor of x plus 2, and then I list the remaining factor of x plus 1. So my LCM in this case is really just x plus 2 times x plus 1, which I know that if I multiply that together, it would just equal this, right? So I'm going to put that in parentheses. It's really x squared plus 3x plus 2. So this quantity was the least common multiple between x plus 2 and itself, because x plus 2 can multiply into x squared plus 3x plus 2, right? X plus 2 times x plus 1 equals that. So that is my LCM for number 8. Okay, like numbers, sometimes you will come across algebraic quantities that don't have any common factors, right? These are both prime factors. X minus 1, the only thing it multiplies to is 1 to equal itself. And then same with x plus 2. Okay, so this is the list of their factors. So then the LCM would be what you get when you just multiply them to each other. So just like with numbers, that can happen with algebraic quantities as well. So that would be the LCM between these two numbers. Now again, these are all going to be handy skills needed in our next video when we look at adding and subtracting rational expressions. For tomorrow, we're just going to practice finding least common multiples and then also adding and subtracting fractions with common denominators. I'll see you there.